I need to tell you guys about stresses as they are applied. So there could be three kinds of stresses, strains, and three kinds of stresses. The first one is called a compression stress. We could also have a tension, or we could have what is called a shearing stress. And usually when we talk about these things, we talk about them in terms of beams. Okay? Think of bridges, beams. Anytime you have a load on them, you want to make sure that they don't break. So the first one is the compression stress. And the way we define it is we take the middle of it and we say force acting from the right onto the left and force acting from the left onto the right. Think of this as a push force. Good? I know it's not kosher, so don't tell anyone, but we're going to call it the push force. What is tension? Tension is always a pull force. So what do you think this should do? Pulling it away?
Yep.
So this will be a pull force, right? And so this will be force of right onto left and force of left onto right. Will they be equal and opposite to each other?
Yes.
Only for isotropic. So for isotropic, absolutely it will be true. But for anisotropic, they may or may not be true. Okay, what is a shearing stress? Same kind of idea, but instead of being pulled parallel, they're being pulled vertically. And as engineers, all of these you have to worry about.
Is there any other ones?
There's components of each one on each other. So for example, if you have you could have like stresses at an angle thing, in which case, for example, you could have like I'll give you an example. So you could have something like this, where you could have a shearing strain that goes like this. In which case you will have to do a component, right? So it'll be like a shearing plus a pushing, so a compression plus that, or it could be a pull. Depends. But yeah, you could have a situation like this where your strains could be different.